Welcome to Chem Mastery with Dr. Z. In this video, we are going to continue talking about quantitative chemistry, and this is part 2. We are going to talk about moles. So, what is a mole? So, 1 mole of any substance is the mass in gram of that substance that contain a certain number of molecules. This certain number of molecule or this certain number of particles of the substance is what we call the Avogadro number. Avogadro number is 6.02 times 10 to power 23. So the particles we refer to here could be ions, could be molecules, and could be as well atoms. So they could be just elements. So any substance we're talking about, it depends on the nature of the substance. So 1 mole of an element is the amount in gram of an element that will contain the Avogadro number of the particles of that element. The element could be monoatomic, or it could be a diatomic molecule as well. So you need to take that into consideration. Um, the mass of 1 mole of any substance will equal the relative atomic mass or the formula mass of the substance in gram. So it's so easy to calculate how much do we have from that substance in gram for 1 mole. So let's have some examples. So if we are talking about hydrogen, hydrogen is one of the elements that exists as diatomic molecule. So hydrogen is H2. So 1 mole of hydrogen will contain 2 grams of the substance or 2 grams of hydrogen. 1 mole of something like iron. Iron exists, it's an element and it exists as a single atom, and 1 mole of an atom will equal the relative atomic mass of 1 mole of iron will contain the relative atomic mass of iron, which is 56, so it's 56 grams. We can apply the same principle for compounds. So something like sodium carbonate. So sodium carbonate, we want to know how much will 1 mole of sodium carbonate contain. So we need first to calculate the relative formula mass for sodium carbonate. When you do your calculation, you're going to find there are 2 sodiums. The relative atomic mass of sodium is 23. So we have 23 times 2 plus the carbon is 12 and we have 1 carbon plus 3 oxygen, each is 16 as relative atomic mass. So 16 times 3. When you do this, you're going to find that the total is 106. So there is 106 grams of sodium carbonate in 1 mole of sodium carbonate. So we need sometimes to calculate the number of moles of a certain substance, and you are usually given the mass of the substance and you are asked to calculate the moles of the substance, or you could be given the number of moles and asked to calculate the mass. So in order to do this, we have this triangular formula. So we have the number of moles, okay, and number of moles we're gonna refer to it as N, equals the mass of the element of the or the compound. So the mass of the substance, the we're gonna give it the symbol M, and then we have divided by the relative formula mass or relative atomic mass for the element or for the compound. So when you look at this, so you're gonna have M and MR. So M here is the mass of the substance, whether it's an atom or it's an element or a compound. N is the number of moles, and Mr is the relative atomic mass or relative formula mass if it's a compound, relative atomic or formula. So let's have some examples. So how many moles are there in 66 grams of carbon dioxide? in order to do this calculation, now they are asking about the number of moles, and we are given the mass. So we're going to use this equation. We're going to look at this triangle. So number of moles will equal mass over relative formula mass. So we need first to calculate the relative formula mass for carbon dioxide. Relative formula mass for carbon dioxide is carbon 12 plus 2 times 16 for the oxygen, and this is 44. 44. This is the relative formula mass. So the number of moles, which is N, will equal the mass, which is 66, over the relative formula mass, which is 44. So this is 1.5 mole. So we have 1.5 mole of carbon dioxide. And you can rearrange this equation in any way to calculate the variable that is needed. So if they give you the mass and ask for the number of moles, you can use number of moles equal mass over relative formula mass. If you don't know the compound and they give you the mass and number of moles, then you can use it to calculate the relative formula mass. And if they give you the number of moles and the relative formula mass, you can then calculate the mass in gram. So we can also calculate the number of moles of an element in a compound, because the number of moles of an element in 1 mole of a compound will depend on how many atoms of that element in that compound. So let's have some examples. So if we have carbon dioxide, so 1 mole of carbon dioxide will contain 1 mole of carbon, but it has 2 moles of oxygen. Let's have a look at another one. So let's have a look at sodium carbonate. So sodium carbonate, 2 moles sodium, 1 mole carbon, and 3 moles of oxygen, and so on. So you can apply this for any compound, just looking at how many atoms is there in the compound, and then 1 mole of a compound will contain the number of the atoms in that compound. So anything, so like here, sodium 2, that means 2 moles of sodium, and so on. So let's have a practice question. So what is the mass of carbon in 4 moles of carbon dioxide? So first of all, we need to know how many moles of carbon is there in 4 moles of carbon dioxide. So 4 moles of carbon dioxide will contain 4 moles of carbons, because each mole of carbon dioxide will contain only 1 mole of carbon. So 4 moles of carbon. So now we have 4 moles of carbon, so we need to calculate the mass. So applying the equation, mass will equal the number of moles times the relative formula mass. The relative formula mass for carbon dioxide is 44, and that sorry the times the now we are only looking at the mass of carbon, so we will multiply the number of moles times the relative atomic mass of carbon, because we are not looking at the mass of the compound, we are looking at the mass of the atom. So we need to calculate how many grams is there of carbon. So the relative atomic mass of carbon is 12. So then we will multiply 4 times 12. So it's 48 grams. When you calculate the number of moles in a reaction, you need first to balance your chemical equation. So balancing a chemical equation is critical to accurately calculate the moles in a chemical reaction. So let's have an example of a reaction and see what is the rule here for calculation of the to balance our equation. So let's look at this reaction here in front of us, which is a reaction between sulfuric acid and sodium hydroxide to give us the sodium sulfate and water. This is a simple acid-base reaction that gives you salt and water. But this reaction or this equation is not balanced. How can we balance this one? So you need to, when you do your balancing, the first thing you look at is your, if you have any metals, so you look at the metals first. So now we have the metal here, which is sodium. So on the reactant side, which is the left-hand side of the equation, we have only one sodium, but we have two sodiums on the left and the right-hand side in the product. So in first thing, we need to balance this. So we're going to add 2 next to the sodium hydroxide to make it 2 sodiums on both sides. So H2SO4 plus 2 sodium hydroxide will give us sodium sulfate plus water. Now let's have a look at the other atoms in the equation to make sure that we have balanced it or not. So the second atom we will look at is we start looking at the oxygen and the hydrogen. So let's count our hydrogens. So on the left hand side now, after we added the 2 next to the sodium hydroxide, we have 2 hydrogens and 2. So there are 4 hydrogen on that side. On the other side, there are only 2 hydrogens here. So in order to have 4 hydrogens on the right hand side or on the product, then we need to add 2 next to the water. So now H2SO4 plus 2 sodium hydroxide will give us sodium sulfate plus 2 water. Okay, now we balance the sodium and we balance the hydrogen. Let's make sure now that the rest are balanced as well. So we only have the sulfur and the oxygen. So there is one sulfur on both sides, so it's balanced. What about the oxygen? We have 4 here and we have 2 from here, so 6 oxygen this side. On the other side, we have 4 oxygens here and 2 oxygen here, so 4 and 2, so there is 6 oxygen as well. So now the equation is completely balanced. So it's 1 sulfuric acid plus 2 sodium hydroxide will give us 1 sodium sulfate plus 2 water. So this is how we balance the chemical equation. You can keep going back and forth until you make sure that all the atoms are balanced. They have the same number of atoms on both sides of the equation. So in a balanced equation, the big number in front of the chemical formula tells you how many moles of each substance take part in or is formed during the reaction. For example, in this reaction, this is a balanced equation. So in this reaction, 1 mole of magnesium reacts with 2 moles of hydrogen chloride to give you 1 mole of magnesium chloride plus 1 mole of hydrogen. So now this is balanced and now we know how many moles react or is produced from this reaction. Now you can also balance your equation using the reacting masses. So if you know the masses of the reactants and the products of certain reaction, you can then work out the balanced chemical equation. So let's have an example and see what are the steps to balance our equation based on the masses of the reactants. So if for this example, we say that 8.1 gram of zinc oxide reacts with 0.6 gram of carbon, that will give you 2.2 gram of carbon dioxide plus 6.5 gram of zinc, right? So the first thing you need to do now is to the to find you need to find the molecular formula mass or the the relative formula mass or relative atomic mass of all of the reactants and product. So the first step, we have the masses. We need to calculate the number of moles. So how would we do this? So we divide the mass of each chemical by its formula mass. our atomic mass, the relative mass. So whether it's relative atomic mass or relative formula mass to give us the number of moles. So for zinc oxide, we have the mass is 8.5 gram. This is the amount of zinc oxide that has reacted. And we divide this by the relative formula mass for zinc oxide, which is 81. So there is zero point 0.1 mole of zinc oxide. And then we have the carbon. So we have the carbon number of moles of carbon. We're going to calculate this. So there is 0.6 gram of carbon and the relative atomic mass of carbon is 12. So you're going to find that this is 0.05 moles of carbon. Moving on, we have for the products, we have carbon dioxide. So number of moles of carbon dioxide produced will equal 2.2 divided by the relative formula mass for carbon dioxide, which is 44. So again, it's 0.05. And then finally, we have zinc. The number of moles of zinc is going to be the mass 6.5 divided by the relative formula mass, which is 65. So there is also 0.1 mole. Then the next step you do is to divide the number of moles for each substance by the smallest number of moles in the reaction. So we find that we only have two values for the moles for the reactant and products, which is 0.1 for zinc oxide and zinc and 0.05 for both the carbon dioxide and for carbon. So we divide all of these values by the smallest one, which is 0.05. So for zinc oxide, it's going to be, when we do the division, 0.1 over 0.05. So this is 2. And then for carbon will equal 1. For carbon dioxide, this is 1. And for zinc, it's 2. Sometimes when you do this step, then the number of moles we get here is not a whole number. If it's not a whole number, then you need to multiply all the numbers by the same amount so they all become whole numbers. So the main idea is to have all the numbers as a whole number. Don't work out with numbers which are not whole numbers. So let's say if you get 1.5 moles, then you need to multiply this by 2, but not just the 1.5 mole, but all the other moles by the exact same number. The idea is to get to the smallest possible whole number for all of the reactants and products. The final step is to start writing your balanced chemical equation, putting the number of moles in front of each substance to get the balanced equation. So now we have 2 zinc oxide plus carbon will give you carbon dioxide plus 2 zinc. This is now balanced equation, and we managed to do this calculation using the masses of both reactants and products. So there's something called the limiting reactant. So what is a limiting reactant? So some reactions, one of the reactants is in excess, and the reaction will stop when the other substance, which is not in excess, is completely used up. So um, an example of this, when you, for example, have a metal and you heat the metal in air, and then the metal gets gets oxidized by the oxygen in air to give metal oxide, then you have once the metal is consumed completely or used up, then the reaction will stop completely, because oxygen and air will be in excess, but once one of the reactants has been consumed or has been completely used up, the reaction will stop. This reactant or this reagent is called the limiting reactant, because the amount of product that is produced will depend on the amount of the reactant in the reaction. So if you double the amount of the reactant, the limiting reactant, then the product will be doubled, the amount of product produced will be doubled as well. You can calculate the mass of the product formed by calculating the mass of the limiting reagent or the mass of the limiting reactant using the balanced equation. So let's have an example for this and see what are the steps that we are going to use to do this calculation. So if you want to calculate the mass of aluminum oxide formed when 130 grams of aluminum is burned in air, then what would we do? First of all, we need to look at or consider what is the limiting reactant in this reaction. So this is a reaction between aluminum and air or aluminum and oxygen. Of course, oxygen is going to be the one in excess, so it's not the limiting reactant. So our limiting reactant now is the aluminum. So before we even start the first step, the most important step for this is to write out the balanced equation. So the reaction is between aluminum and oxygen that gives you aluminum oxide. When you balance your equation, you're going to find that 4 aluminum will react with 3 oxygen to give you 2 aluminum oxide. So this is your balanced equation. After you balance the equation, you're gonna start with the second step, which is to work out the formula mass of all the reactants and the products that you want. You will only here consider the reactants and the products you want. You're not considering anything else. So the formula mass of the formula mass, relative formula mass of aluminum oxide equals 102 and the relative atomic mass of aluminium equals 27. These were given here because in your exam they're not going to give you the relative atomic mass of the different atoms, but you need to look that out in the periodic table that you will be given. The third step is to find the number of moles of all the substances that you want their masses. So you want the number of moles of aluminum. We know how many, what is the mass of aluminum that has reacted. And then based on calculating the number of moles of aluminum, we can calculate the number of moles of aluminum oxide. So let's start off by finding the number of moles of aluminum. So number of moles N will equal M over MR. So this is the 135 gram divided by 27, which is the relative atomic mass for aluminum. So this is 5. So the number of moles of aluminum that has reacted is 5. Now we need to use the balanced equation to work out the moles of the other substance, which is the aluminum oxide. So when we look at the balanced equation, you can find that 4 moles of aluminiums react to give you 2 moles of aluminum oxides. So if we have 5 moles of aluminum, that means they will give us half that amount of moles of aluminum oxide. So only 2.5 moles of aluminum oxides will be produced. Now, for aluminum oxide, we have the number of moles, we know the relative formula mass, so we can now calculate the mass of aluminum oxide produced. So the mass of aluminum oxide produced, M, will equal N times the MR, which is going to be 2.5 times MR, which we calculated as the 1.2. So this is 255 gram of aluminum oxide. There is a very important note here that when we did all this calculation, we assumed that 100% of the aluminum will react with air to give you the product. So we assumed that there is 100% yield of our reaction. But this is not the case in real life. We will talk about how to calculate the percentage yield later. So what about gases? So we talked about how we calculate the number of moles by using the mass and relative formula mass or relative atomic mass. But we don't calculate the mass for, or we don't measure the mass for gases. We cannot measure the mass of the gas. We can calculate it using a reaction, or using the equations, but we cannot actually measure the mass of a gas, but we can measure its volume. There is a fact here that says that at the same temperature and pressure, equal number of moles of any gas will occupy the same volume. So at room temperature and pressure, which is 20 degrees Celsius, and pressure of 1 atmosphere, we will find that 1 mole of any gas occupies 24 decimeter cubed. So 1 mole of any gas at room temperature and pressure will occupy 24 decimeter cubed. So you can use this equation to calculate, to find the volume of a known mass of any gas. So the volume of the gas in decimeter cubed will equal the mass of the gas in gram over the relative formula mass of that gas times 24, which is basically the volume of 1 mole of that particular gas. So let's have an example. So what would be the volume of 319.5 gram of chlorine at room temperature and pressure? So the volume of chlorine will equal the mass of the gas in gram, which is 319.5 gram, divided by the relative formula mass of chlorine. Chlorine is 71, and we multiply this by 24 and you will be given 108 decimeter cubed. You can also calculate the volume of gases in reactions. For reactions between gases, you can use the volume of one gas to calculate the volume of another. So instead of using the moles, we can use, or the masses, we can also use the volume. So, for example, how much carbon dioxide is produced when 30 decimeter cubed of oxygen reacts with carbon monoxide? In order to do our calculation, we need to write the balanced equation first. So the balanced equation is that 1 mole of oxygen reacts with 2 moles of carbon monoxide to give you 2 moles of carbon dioxide. That means 1 mole of oxygen will give you 2 moles of carbon dioxide. And this is the same for the volume. So 30 decimeter cubed of oxygen will give you double that volume for carbon dioxide, so 60 decimeter cubed of carbon dioxide. Because we can actually measure the volume of gases, but we cannot measure the mass of the gas.